Hello everyone, welcome to my video tutorial. This time we will be talking about two-dimensional scaling. 2D scaling. Scaling a coordinate means multiplying each of its components by a scalar. So we will have a scalar. There are two kinds of scaling. One is uniform scaling and the other is non-uniform scaling. Uniform scaling means this scalar is the same for all components. Suppose we have a scalar on the x-axis, s of x representing scalar on the x-axis, and scalar on the y-axis, s of y. In uniform scaling, s of x and sy should be equal. So here we have which is equal to 2. Now we have a small house which is scaled 2 times, and on the right hand side we have a bigger house. Okay, so how do we get to this object? Is that we multiply each of these points by a scalar which is 2, a common scalar. So if you see this point belongs to 2 on the x-axis and 1 on the y-axis. This point belongs to 5 on the x-axis and 1 on the y-axis. Here same thing, 5, 3, and here also we have 2, 3. Now let us just consider these 4 points for the moment. In uniform scaling, we will multiply each of these components by the same scalar which is 2. Alright. If we multiply 2 into 2, we will get 4. If we multiply 2 into 1, we will get 2. So likewise, this 5, 1 will become 10, 2. Here also 10, and 3 into 2 will be 6. Okay. Now here also 2, 3 will become 4, 6. That means we are multiplying each of these components by 2, which is the same scalar. Alright, so this is a uniform scaling. We should remember that in uniform scaling, if we have a scalar sx and sy, this sx and sy should be equal always. Alright. Now let's move to non-uniform scaling. Here we have a different scalar. That means your scalar s of sx and sy should not be equal. This is your formula for non-uniform scaling. Your scalar on the x-axis is 2. Your scalar on the y-axis is 0.5. Now let's see this non-uniform scaling. This point is 2, 1. This point is 5, 1. Here we have 5, 3. Here we have 2, 3. Alright. Now the scalar are not equal. Therefore, to scale on the x-axis, it will be multiplied by 2. To scale on the y-axis, it will be multiplied by 0.5. Now let's consider this point. 2 is on the x-axis, therefore it should be multiplied by 2, which we get 4. And 1 is on the y-axis, it should be multiplied by 0.5, and then we'll get 0.5. Alright, now this point has become 4 on the x-axis and 0.5 on the y-axis. So this is your 0.5. Alright, now let us consider this point again. 2 is on the x-axis, it should be multiplied by 2, we get 4, and 3 is on the y-axis, should be multiplied by 0.5, we will get 1.5. Alright, so this particular point will become 4, 1.5. So this is your 1.5. Alright, so you can check out for all of these points. Here you can take this point, this point, and all these points can be scaled. Now we should remember that in non-uniform scaling, we can either reduce on the x-axis or on the y-axis. Alright, and it will only matter by the scaling parameters. Now how can we represent this in matrix form? We have scaling operation, as we can see, is this new parameter x dash should be equals to your scaling parameter s of x on the x-axis and your original x. Okay, this is your original, this is your new. Likewise, on the y-axis also, y dash should be equals to sy y. Alright. This formula can also be represented in matrix form. This is your matrix form. Now let us try to find out the matrix form. X dash will be equals to s of x into x plus 0 into y. Alright, it goes like this. So s of x plus 0, 0 into any number is 0. So x dash will be equals to s of x into x. This is the same as this. Now let us consider y dash again. This one. Y dash will be equals to 0 into x plus s of y into y. Alright. 0 into any number will be 0 plus s of y, which will be equals to y dash will be equals to s of y, y. This is the same as this formula. Alright. Does non-uniform scaling preserve angles? This is a big question, and you should answer as no, it cannot preserve angles. Now let us consider this. Consider the angle alpha that the vector makes with the x-axis. Let us draw x-axis. Suppose we have here 1, 2. Suppose this is your 1. Consider the angle that the vector, is your vector, the vector 1, 1 makes with the x-axis. Alright, so this is your vector. Let us assume this is your alpha. Okay, scaling y by 2 creates the vector 1, 2. Alright, now we will scale this vector 1, 2. Now let's see, scaling y by 2 creates the vector 1 and 2. Suppose on the y side we scale it by 2. Okay, that means 1 is multiplied by 2 on the y-axis. That means it will become 2. Now we have this vector. That means x is equals to 1 and y equals to 2. Now we get this point. And if we make a vector like this, the angle, suppose the angle beta that it makes with the x-axis is different. Now let's see which is greater. If we check out this angle made by 1, 1 and angle made by 1, 2, as you can see, this beta is much larger. Okay, so that means alpha is smaller than beta in this particular case. Okay, they are not equal at all. So alpha and beta are not equal. That means, does non-uniform scaling preserve angle? This question is to be answered as no. No is the right answer. Okay, that is all for today. Thank you very much. Let us meet again on the next video lecture. Thank you.